Next, we are discussing some components of expressway security, which we have discussed a few, like the registration restriction policy, which is a part of the components of expressway security. We'll see some more, like about the certificates, as you mentioned yesterday. We'll also see a lab. So, in our lab, as that was not part of VII, you won't be able to perform it, but I will demonstrate to you and I will share steps with you so that you can perform it if you have to do it in your environment. So that's what we are going to discuss here first. So about certificates on expressway, there are a few things we need to understand about, like the protocol TLS. Yeah. So TLS is transport layer security. Its predecessor was another protocol SSL. Yeah. Secure sockets layer, both frequently referred to as SSL also. It's one and the same thing. It's just TLS is an advanced version of SSL. And these are cryptographic protocols which provide communications security over a computer network. So it's used in various use cases are there for TLS for different protocols and communications. So this is a TCP protocol as a suite of TCP protocol, and it primarily aims to provide privacy, data integrity between the two communicating hosts or the applications. So this use a server client model applied to TCP connections like SIP. So we can create a secure SIP, secure HTTP communication. It provides confidentiality. It provides identification, commonly uses certificates for that, which we will see here, that provides authentication and integrity. So these are the features of TLS. So as I mentioned, SSL or TLS, both are the same. It's just TLS is the now new version of SSL. So it is a client server application such as for web browsers, these are the applications which use client server models. So like web browser, emails, servers, and VoIP commonly, voice or video networks commonly use the TLS protocols to prevent things like tampering of information or eavesdropping. Eavesdropping means like secretly hearing to the communication or the traffic, basically used in voice and video, yeah, as an intrusion. So to prevent these kind of uh, intrusions or threats, we can use TLS just as a method to secure the communication. So the protocols uh, these applications use must choose or not use TLS. It's the easiest way to segregate the information is to use different port numbers. So what we specifically do here are, let's suppose we are applying TLS to SIP and the default port is 5060 for SIP. We use a different port number, let's suppose 5066 for that when we are creating this tunnel of TLS to secure it. It's like a proxy over it. Yeah, we will see that also. So for example, in HTTP, the unsecure HTTP port 80 is there, and then as we apply TLS to it and HTTPS, use 443 port. Yeah, so it's not a default port or the predefined port. It is the port which is generated or which is allocated to the secure HTTP. Yeah, so as TLS encryption is applied to it, it becomes HTTPS and the port number is 443. So same way for any communication we use by changing the port number to it and create a TLS version of that protocol. And next, once the client and server have agreed to use the TLS, so if on both the sides TLS is enabled, they negotiate a stateful connection by using the handshake process. In this handshake process, there are some number of steps which it goes through, like master secret is never exchanged. It is derived from the pre-master secret. Then RSA keys are used. The pre-master is sent encrypted from the client. Then DH is the key type which is used called Diffie Hellman. These are some encryption types which are used in that. Yeah, for the pre-master secret, which is derived, and session keys are computed from master key. So these are set of keys which and encryptions which are used for generating the encrypted secure keys. Then client and server stop using the public-private key pair, which is called asymmetric encryption, and start using the shared session keys once they have exchanged the public-private keys and authenticated them. Then the next is the shared session keys, which is called symmetric encryption. Client does not need a certificate in a server-client handshake. Then client certificate is checked during the TLS negotiation, in which fields like hostname, which is FQDN format, against the certificate, the expiry, revocation status of the certificate, digital signature of the certificate, all these are checked. So there are ways like either you can self-sign the certificates or get it signed through the CA authority. So self-signed certificates are imported to the local trust store for verification. So we can use a local CA certificate authority, or it can be through a public CA. So it has to be CA signed, where it checks for certificate chain validity. Then TLS handshake with mutual authentication. So in mutual authentication, TLS with client authentication is also possible. So both client and server needs to have the certificates, and it should be authenticated. So for example, in SIP TLS signaling between SIP endpoints and CUCM, CUCM SIP trunk to another CUCM cluster, or CUCM SIP trunk to Expressway is mutual TLS on CUCM side, and can be TLS or mutual TLS on Expressway side based on the configuration. So these are the use cases of the mutual authentication. Then this is a high level TLS or secure RTP setup here. So in this order, we can see to secure voice or video over IP, right? Multiple technologies must be understood. So remember, the most common VoIP communication used today is SIP, which is a standard protocol, session initiation protocol. It is the communication protocol now for signaling and for controlling the media communication sessions for voice and video calls. So for secure transmission of these SIP messages, the protocol may be encrypted with TLS. So to encrypt the SIP messages, we can use TLS over it, as that is also recommended from security standpoint. Then media identification, negotiation, which is all done with the help of SDP in that session description protocol. This is a protocol which is used for media negotiation in SIP. Within this, if you have TLS enabled, it can exchange the keys. So within the session description protocol, which contains the information about the bandwidth, the codecs used, and the capabilities, so it can then contains the keys for authentication for the encryption. So for secure transmission of these SIP messages, protocol TLS is used, and media identification and negotiation is achieved using SDP, and SDP use a master key exchange for the transmission of media streams. For the transmission of this media stream like voice or video, SIP uses RTP protocol, but we can also use secure RTP further to add to the security. Unencrypted SIP generates a port 5060. This is called unencrypted SIP port. We have an encrypted SIP port by default of 5061. Right? So to secure the end-to-end traffic, that both endpoints must use TLS SIP to the SIP nodes, and every SIP node's trunk to another SIP node, which used to pass the communication. If a single link passes the SIP communication unencrypted, all traffic should be considered compromised in that case. So to remove that, we can further add security using the certificate. So that is the commonly used method here. So we use certificate authorities. So certificate authority certificates are used. So on behalf of receiving the certificate request called a CSR, certificate request, the CA, which is a certificate authority, performs an identity verification, which consists of information like these: domain validation, organization validation, extended validation. So these are the things that the CA performs as an identity verification, domain validation, organization, and extended verification. So the trusted certificates are very important to create secure connections. That's the reason we need to have certificates. This part of process is where the CA comes into the solution. So this is the one that provides a trusted certificate, and it verifies and creates a trust between the devices. So these certificate authorities are used commonly both as public internet CAs or private networks to issue the digital certificates, which contains identity credentials and bind them to SSL or TLS cryptographic keys by default, which is a default process within the certificates. So since the CAs are like the trust providers, so these are also called trust anchors. They must conduct some checks into the identity of the applicant. Once they have performed the checks, then they will provide a trusted signed certificate, and that signed certificate needs to be installed on the expressway or on our devices and anywhere you want to create the digitally signed certificates. Yeah, so certificate verification is done by the CA. Then some certificates on Expressway are, we can have certificates options like single host or domain. For single host or domain, we can have multiple hosts or domain up to any numbers depending on the certificate type. Or we can have multiple subdomain wildcard certificate. Now this one is not supported on Expressway. So these are the two options for us here, which performs domain validation, organization validation, and extended validation. Then certificates on Expressway, certificate options and types are on Expressway E, it requires a public certificate. A standard certificate protects a single host or a domain. Wildcard certificates are not supported on Expressway out of the different types of certificates available. In case of multiple hosts, multiple domains, or multiple subdomains, multiple SAN certificates have to be provided. These are called like subject authority network, something like that. The cost varies depending on the number of SANs, and the DV being is the cheapest. So this is a method we can use, but in case of Expressway E, because it will be a public certificate, so the cost will vary. The process remains the same. It's just the certificate authority will be different. For Expressway C, you can use a private certificate authority, get it digitally, sign internally, and install it on the server on Expressway C. The same process is on the Expressway E. It's just that it will be signed through a public CA. Right? So this is the process where we can see the certificates on the Expressway. So let's suppose there's a firewall in between, and we have Expressway C and Expressway E. So we have an enterprise network, then we have the DMZ zone and outside network. To secure these connections, it is important to have certificates on the Expressway C and E, and is a prerequisite also. So in the collaboration networks, like in this type of architecture, it is easy to secure uh, and it is important to secure all enterprise network information. You can just make a private network behind the security of the firewall, so the enterprise network can be easily secured. But the problem comes in the order of the outside network, when the communication is coming from outside. To secure that, there is the importance of using certificates and securing the network. So Cisco has Expressway series or VCS solution, which all are required to have these certificates. Both are capable of the Cisco proprietary Accent protocol, which allows the secure firewall traversal. And the best practice of setting the expressways beginning with the edge always as the part of the certification here. So which is usually placed in between the two firewalls, and the authentication happens with the help of the certificates. So we will see that how we can configure that in the lab. Now in the expressway architecture, we can see that Expressway E is a traversal server installed in the DMZ zone, and Expressway C is the traversal client. Expressway C initiates the traversal connections outbound through the firewall to the specific ports on Expressway E with secure login credentials. Once the connection has been established, Expressway C then sends the keep alive messages. These are like the periodic messages sent from Expressway C to Expressway E to maintain a relationship with the Expressway E. So to maintain that connection, it regularly sends keep alive packets. Then when Expressway E receives an incoming call, it issues an incoming call request to Expressway C, which then routes the call to CUCM to reach the caller or the endpoint. The call is then established and the media traverses the firewall securely over existing network. So for all of these things, we require the certificate check on the Expressway. So during the validity check, the standard browsers make sure that the host name matches the SAN and the certificate has been signed by a trusted CA. On Expressway, this is optional and activated by TLS verify mode set to on and configurable per zone. So for this validity check, we have another option as TLS verify, which is recommended to be used, but along with that, we have to use certificates. But if in case you have not the certificates installed for some communications like for MRA, we need to have it. Without that, MRA would not work. But for another type of calls, like for outbound, it would work with the help of TLS, as TLS itself can provide some security and verification between the client and server. So if you do not set up TLS verification, TLS can be set up with self-signed certificate. So either you can use TLS verify mode in such cases or use a self-signed certificate. In both cases, the call will be encrypted, but if TLS verify mode is on, it authenticates the other peer also. Some security features on Cisco Expressway are registration policies also, which we have discussed already. So without any security policies implemented other than the registration conflict policy, all devices are allowed to register. So it is good to have a restriction policy as a recommendation, which we saw in allow list or deny list. This is just the same behavior of allow list, how it works, which we have already done. Deny list. All right, then in those, we can also use the same patterns to match the allow or deny endpoints based on exact, prefix, suffix, or regular expressions. For registration authentication, which is allowed to register, there is SIP authentication, which uses digest, HT23 authentication, which uses H235 type of protocol, which is used for authentication. Both use message digest 5, MD5 authentication, yeah, for encrypting the information. And MD5 uses a timestamp as a part of encryption key. Now, what is timestamp? Timestamp is an information which checks for the time synchronized. So if at the same time the request has been sent and received, then only it will verify it. And for that, an NTP server is required. And both the endpoints should be the part of the same NTP, should be the clients of the same NTP server. That is a timestamp. Okay, that is it about the components of security. We will